Hi everyone, I'm Miss Koenig, and this is a quick video tutorial on solving algebraic inequalities. This is the second video in a two-part video series on solving algebraic inequalities. If you haven't seen the first yet, I would suggest you go back and check that out prior to watching this one. If you're ready for this one, let's go ahead and jump in. Our first example has a multi-step, we would call it a multi-step inequality, that has parentheses. So you should be thinking, okay, I need to distribute. I need to isolate the term with the variable. I need to consider that there are negatives in my inequality and a few other things. If those aren't the thoughts that first pop into your mind, you might think about going back and watching the first part of this video series just to get a grasp on solving inequalities. Otherwise, let's go ahead and solve. So the first step, anytime you see a problem that has parentheses, is to distribute. Now you can divide by that -3, and in some classes you may discuss that as an ulterior option. For the sake of this example, I'm just going to distribute that -3, giving me -6x plus -15 or -15 greater than or equal to 12. Now, when you're solving, if you're new to solving two-step or multi-step equations, I suggest putting a line down that symbol just to help you remember that there are two sides to an inequality, just like there are two sides to an equation. Whatever you do on one side, you have to do to the other. Now, the ultimate goal here is to get the term with the variable by itself, which means I need to get rid of that -15. In order to do so, I'll use opposite operations, and I will add 15 to both sides. When I do that, the -15 plus 15 gives me a 0, leaving me with only -6x on the left side of my inequality. On the right-hand side, I'm left with 12 plus 15, which is 27. Now, thinking like this is an equation, the same process will happen for isolating that variable, with one little caveat because it is an inequality and not an equation. So you should be thinking -6 is multiplied by x, and the opposite operation is to divide. Now, as you should have already learned prior to coming to this video, anytime you divide by a negative in an inequality, your sign flips. So you'll notice that I still have that equal to piece in my sign, in my symbol. It used to be greater than or equal to, now it is less than or equal to. The only thing it does is flips and faces the other direction. Now 27 doesn't divide nicely by -6, but I can think of it as a fraction and simplify. Both of those divide by 3, so this could be -9 over 2 or -5.5. So what I've learned here is that x is representative of numbers that are less than or equal to -4.5. Let's go ahead and plug in a value just to double check that we did the right thing. It helps to double check when you have to flip the sign. So I'm looking for a value to plug in that is less than or equal to -4.5. Just for the sake of finding the easiest number, I'll use -5. That's just a half step lower on the number line. So when I plug that in, I'm really just plugging it into the left-hand side. I've got -3, and then in parentheses, 2 times -5. I'll actually add double parentheses there and change that to a bracket just to make it a little easier to see, plus 5. And I'm looking to see that the answer that I get is greater than or equal to 12. If it is, that tells me I've gone in the right direction with solving. If it's not, I may have made a mistake. So I'll start inside those brackets. 2 times -5 is -10. So I have -10 plus 5, and eventually times -3. -10 plus 5 is -5. And -3 times -5 is +15. Now that's a value that is greater than or equal to 12, which leads me to believe that my answer here is correct. Let's try another. This example may look a little bit easier because it doesn't have parentheses, no distributing, but it does have variables on both sides of that less than symbol. So let's go ahead and take a look. Now, just like when you're solving an equation that has variables on both sides, or really any equation at all, I'm going to use a line, especially if you're a beginner. That's really helpful to balance the left side and the right side. Now, the first step, anytime you have variables on both sides, is to first look and see if you can simplify anything. In this case, I cannot. Then I want to get my variables on the same side, so I need to add or subtract one of them. In this case, both are positive, so the only way to move one of them is to use the opposite operation and subtract. I'll subtract the 3x from both sides, and you'll notice that I'm subtracting it from the like terms. So for example, I did not subtract it right here because 9 doesn't have an x, so it's not a like term. Now when I subtract that on the left-hand side, 3x minus 3x is 0, so I'm left with just 4. 5x minus 3x is 2x, and then I bring down the minus 9, and I've brought down my less than symbol. From here, you're really just solving a two-step inequality. I need to isolate the term with a variable, and I'll do so by adding 9 on both sides. Again, you're using opposite operations. That gives me 13 on the left side. Negative 9 plus 9 is 0, so the only thing left on the right-hand side is my 2x. Again, you should be thinking opposite operations. The 2 and the x are multiplied. In order to undo that multiplication, we'll need to divide by 2 on both sides, which gives me 6.5. Now, it's not often that you see an answer that has the variable on the right-hand side. You can leave it that way, or you can flip it around. The caveat being, if you're going to flip the x and the 6.5, you need to flip the symbol to go with it. You can't flip those and keep the symbol the same. Either way, you should notice, if you think of this symbol as like a Pac-Man, it's eating the x on both situations. That kind of tells you that these are equivalent answers. It should be pointing toward the same value on both. Now again, I want to plug in something to verify that my answer is correct. This time, because it's a two-sided inequality, I'll plug it into both sides and just make sure that I get something that works. I'm looking for a value that's greater than 6.5, so I will use 7. Now 3 times 7 I know is 21, and 21 plus 4 is 25. And I'm hoping that that's less than what I get for the right-hand side. 5 times 7 is 35, and 35 minus 9 is 26. 25 is less than 26. I've gotten a true answer, which leads me to believe that the answer I got down here is correct. Let's try one more. Now this last one combines both of the things we've talked about so far, distributing and variables on both sides. Let's jump in. The first thing I'll do is distribute that negative 4. Now we've talked about in the prior video how if you're multiplying by a negative or dividing by a negative in an inequality, you should be switching the side that your sign is facing. In this case, I'm not actually multiplying that side by anything that wasn't there before. The negative 4 just needed to be distributed. I'm not multiplying both sides by anything or dividing both sides by anything. So in this case, I don't actually need to move my sign. It's going to stay greater than for now. Now again, I need to get my variables together, so I will use an opposite operation, and I'll actually add this 4x because it was a negative x. And a negative and a positive are opposites. That's what gives me the 0 on the left-hand side. I'm left with 36 on the left-hand side. I keep my symbol the same. I've got 6x and then 3. From here, I want to isolate that term with a variable, so I'll subtract 3 from both sides, giving me 33. And then I'll divide by 6 on both sides. Now 33 doesn't divide by 6 nicely, so again, I'll leave it a fraction, 33/6, and I'll simplify. Both of those can divide by 3, which would leave me with 11/2, or 5.5. Now again, remember that you can rewrite this answer. Often you'll want to see the variable first. If you do that, make sure that you flip the sign to match. So I end up with a value that says x is less than 5.5. Again, I want to check my work. Now, anytime you're looking for something less than a positive number, 0 is a wonderful number to plug in. It's easy to use, harder to make mistakes with. So let's do that. I want to do negative 4 times 0 minus 9 on the left-hand side. And I know that 0 minus 9 is negative 9. Negative 4 times negative 9 is positive 36. I'm looking to see if that is greater than what I get on the right-hand side. On the right-hand side, I have 2 times 0, which I know is 0, and then I add 3, and I get 3. 36 is, in fact, greater than 3, which tells me that this answer is probably headed in the right direction. Now here's a basic list of steps for solving a multi-step inequality, whether it's with distributing, combining like terms, moving one variable to the other side, so on and so forth. If you've seen the previous video on solving inequalities, you'll notice that these instructions look similar. I've kind of simplified the process. First, try and simplify. Second, get the variables together on the same side, then solve, then graph. A little less explicit, but this should cover every scenario you could come across with an inequality like the ones we were solving on this video. I hope this helps you understand how to solve those two-step and multi-step inequalities, including any that involve distributing, maybe even combining like terms. Thanks for being here. I really appreciate it, and I'll see you next time.